So this is about completing the square. That's what this is called. It's called Complete the Square. And I want to tell my favorite Complete the Square story. So I was over at the District Service Center, which is this main office for the school, and they were doing this awards ceremony. This kid was getting an award, and I was there. Somebody else had invited me because I had made a difference for them in helping them, get a really good score on the ACT or something. And so they get to invite one person. So I got invited, but this kid, who I hadn't even been invited by, he actually was talking to me and he said, I remember when you taught us Complete the Square, and I thought of it at just the right moment on the PSAT test. And he got National Merit, so that means he did really well on the PSAT test. And National Merit Scholars can get like a full ride scholarship. And he said, basically, giving you part credit for the fact that I got National Merit because I remember I used that Complete the Square thing to solve that problem. So I'm going to show you one. This is what he did. Now, I don't know exactly what the problem was, but here's an example where it's already in vertex form. You'd be able to tell me the vertex within 5 seconds if you know what you're doing. What's the vertex? 3,7. Good. But what if it doesn't look like that? What if it looks like this? And you're trying to find the vertex real fast. Well, that one doesn't factor, which makes it way harder. And it isn't in vertex form. So what are you going to do? You're going to do something called Complete the Square. Now watch. See if you can learn this from one example. If you're amazing at math, the teacher can show you how to do something one time, and then you know how to do it. Let's see if you can get it. All right. The first thing I'm going to do is move the +1 over. I'm just moving it over so I have space. Do you get mathematically nothing really changed? I just made space. Okay. Next thing I'm going to do is I'm going to figure out what the perfect number would be right here so that this thing would factor, and not only factor, but factor perfectly. I'll show you what that means. To get this number, the question mark number right there, I am going to do a little calculation in my head called Heffen square. I'm going to take half of the 8 and square it and put it there. What is half of the 8? Square it. 16. You were doing square root. So half of the 8 is 4. 4 squared is 16. Would you agree if I want to, I could add 16 to both sides of my equation, but don't? Would you agree I could if I wanted to? But for this application, I'm going to do something you've never done before. I'm going to add 16 there, and I'm going to subtract 16 here. Do you agree that that still keeps the equation balanced? Like, even though I added 16, I also subtracted 16, so now it's still equal. If you can't handle that, if that bothers you too much, then I guess you have to add the 16 over here, and then guess what? You'd subtract 16 on both sides, and then it'd be over there. You get what I'm saying? All right, so I added 16 and I subtracted 16. And then if you feel like that was completely useless, I get it, because if I just combine like terms, it would be gone, and that would have been useless. But what I'm going to do is factor this to perfect square factoring. Do you get that that actually works? X plus 4 times x plus 4 would be x squared plus 8x plus 16. Can you do that in your head? At least the x squared and the 16 you should be able to do in your head. Okay. If that's too much, then just factor it like a normal person. Make 2 parentheses, and you'll realize, oh, they're the same. X plus 4 and x plus 4 makes this work. See what I mean? Okay, so I factored it. And now what do you think I'm going to do at the end? Just take a wild guess how the problem ends. Add these. What do they make? Negative 15. There we go. Done. And now I know the vertex, don't I? What's the vertex? Negative 4, negative 15. You see how fairly quick that was? All right. Let's see if you can handle it. Y equals x squared plus 6x minus 2. And I always say if you can factor it, you should, but it's not going to factor. So then, what did I do first? Somebody with a good short-term memory, what did I do first? Yes? Move the negative 2 over. Good. Do you remember what I did next? Yes? Yep. And then that was a little formula that I called half n square. So in this case, not the x, don't do the x, just do the 6. So half of the 6 is 3 and then square it. So if I add plus 9 here, why did I do that? So that this would factor. Anwishan, what did I do next?
You subtract 9.
Yes, because I added 9, I now have to subtract 9. I did give you the alternative. You could add 9 here if you wanted, but then to get it over there, you'd subtract 9. And so it's faster to just go right there. And please finish it from here. And you'll know the vertex. It's that easy. So, of course, they get more complicated when... Did you notice that every time I did half n squared, it came out to a nice number? Do you get sometimes when you take half of something, it doesn't come out nice, it comes out to a decimal? So that's one complication we'll have to deal with, but let's just make sure you've got it when they're easy. All right, so this should have factored to x plus 3 and x plus 3, but I'd rather save some time and just go x plus 3 squared. And then those two together make minus 11. Raise your hand if you had that one right. Cool. All right, so one more without any more coaching. Y equals x squared plus 10x. Again, I'm giving you one that's easy because half a 10's easy, right? But what if I said 9? Half a 9 isn't so easy. But plus 4, and that one doesn't factor. So I guess you'll have to do this complete the square, it's called. You're making a perfect square. That's why it's called completing the square. You're making a perfect square, meaning it'll be like x plus 2 and x plus 2. Brooklyn, first step. Move the 4 over. That's the first step. What's next? Which is 5, and then what? Which is plus 25. We did that on purpose because that'll factor perfectly. All right. And it'd be really easy to right here think that the answer was y equals x plus 5 squared plus 4, but then I would be wrong. Zep Zelka, can you tell me what to do next? There's a minus 25 here. And put it with the 4 and you make what? Negative 21. There you go. I think you're probably ready for the step-up version. Y equals x squared plus 3x. Ew, can't do that so nice. And then right off the bat, I'm going to put my plus 1 at the end. I'm leaving myself space right from the get-go because I know the deal. All right, so watch a pro do this because you might think you should use decimals. You should not. They are way worse. Okay, I'm going to do half the 3, which is 3 over 2. I know it's 1.5, but I'm telling you the decimal way sucks. Don't do it. And this will always be positive because I'm going to square it. Do you get this? Is always is a big word. Always be positive right there. Because I'm going to square the number that I took half of. But how do I square it? I go like that. Half n squared. You get how 3 over 2 is half of 3? And then I squared it? Couldn't I just say 9 over 4? Yes, I could, but there's a reason I'm not doing that. Now, I just added, would you agree that's the same as 9 over 4? So then I'm going to subtract 9 over 4 here. Trust me, it's better to square it when it's on the outside, and it's better to not square it when it's on the inside. You can if you really want, but let me show you why it's so nice to leave it alone in there. Because, look at my answer coming out so nice. X plus 3 over 2. And then, as always, these are squared. And then I just have to add these together. Oh, I guess I need to know how to add, or in this case, subtract, a fraction and a whole number. Man, that almost seems like something that would be on the basic 20. Because you're supposed to know this, and I know some of you don't right this second. But I'll remind you, we just have to times this one by 4 on the top and the bottom. Then they'll have a common denominator. Then I'll be able to put them together. This is why I want you to know that stuff, because in a moment like this in Algebra 2, you're expected to know how to add fractions like 9/4 and 1. Okay, so then these can go together, and that's going to make negative 5/4. Now, I know the part that probably is bothering you is how this went right there. But I'm going to ask you to look back at this one. Did you ever notice that that was the square root of 25 is what it went there? And on this one that we did, it was the square root of 9 that went right there. And so by not squaring this thing, but saying squared, I could preserve that it was a 3 over 2 right there, and it can just go right down in there. That's 3 over 2. Cool. And even though it's really gross, I've got my vertex. If at this point you want to make them decimals, you could, but you don't have to. Might as well just leave it as, careful, negative 3 over 2. It's always the opposite of what you expect, right? And then comma, I trust the outside, negative 5/4. There is no way you could have done that without the method I just showed you. Like, nobody's doing that in their head. But now that you know this method, you could do this in your head. You really could. All right. That's the vertex of the red equation that's right here. X squared plus 3x plus 1. All right. Now, you watched me do that one. Well, the key moment was right here. And then I knew to square them both and put them here. And then I knew how to get common denominators and add this together. Let's see if you can pull all of that off. You ready? Y equals x squared plus 5x plus 1. One step at a time. First step is to write that down. You gotta write it down. Second step is, think about half and the squared. But remember, leave it as a fraction. So Leo, what goes right here?
5/2.
Close? Yes. 5/2 squared. And now it'll factor. I wish I would have moved my plus 1 over a little further, so I will. I'll just move my plus 1 over a little bit more to make room. To make room for what? Lydia, what should I put here? Hint, it's not 5/2 squared. Negative, first of all, very good. You remembered to do the opposite of what we did here. 25/4. Perfect. Libby, would you lead us through how you change this so that you can somehow do that adding fractions problem?
Well, first you have to get this in the denominator to 1, so
Like that?
yeah.
Excellent. Okay. And now we're pretty much ready to do the whole thing, the final answer. Can you, everybody check if you and your partner next to you have the same exact thing for the vertex? Elizabeth Reed, if you could check with Kate, that'd be good. Five over two goes here. And negative 21/4 goes there. Raise your hand if you had that one right. Awesome. Okay. Now, I'm going to do something I almost never do, which is I'm going to teach you two lessons at once today. Because if I just add on one more hard kind of complete the square that we would have had a whole lesson on tomorrow, then tomorrow I can just do like one review problem. You can have a whole hour to work. All right. So we're going to have a little bit longer lesson today. Not much, just one more add-on to this. And then you'll be able to handle the hardest kind, which is what I would have to teach you tomorrow. But I feel like you're doing so well at this. Everybody seems like they're getting them right. That if I add this one last thing, then I get tomorrow is just like a couple review questions, like 5-minute lesson, and then the whole hour's work done. Okay, so here we go. This is the hardest kind. What if there's a 2 in front? All right. So, same idea. I need room to work. I'm moving my +5 over. Do you get we start exactly the same? Now, this next part is going to kind of blow some people's minds. But if I just ask you, what do you think I do next? I don't think there's going to be many people that know. Ooh, 2 people. What do you think we do next? You know what to do? Give it a shot. Leo, do you think you want to share?
Maybe factor up.
Factor out 2, you're right. If you can factor it, you should. And if you weren't sure what to do, did you even think about how, if it's really hard, you should think about factoring? Because it is often the answer. Okay, so I factor out the 2. But wait, some of you are like, but you can't factor a 2 out of the 5. You're right, but we don't have to. This may be the first time you've ever factored out just part of an equation. It's legal. You don't do it very often, but we're doing it here. And I leave the +5 way over here. I don't have to factor the whole thing. I can just factor the first part. And now, what do you think I'm going to do next? Take a guess. I haven't told anybody. Just take a guess. What do you think? Half and square. Yes. That's half the 2. What is it? 1. What's 1 squared? Now, normally, we would do -1 right here, but we don't. Who is smart enough to figure out what we do? Yes, I said do. What do we do? If we're not going to put a -1 there, can you figure out why? Somebody's going to get this. I know somebody's going to get this. The whole point of those 2 is they're supposed to cancel each other out. And we should...
Subtract 2,
Why? Wait, where'd you get that from?
because you factored the 2 out, so you have to take that into account.
I love the way you said that. You factored the 2 out, so you're going to have to take that into account. Here's another way you could say it is this. Would you agree if I actually multiplied this into everything, the 2 is going to hit that 1 and make it worth 2, and we got to cancel that out by using... This has to get multiplied by 2 also, so we need -2 there. Do you get what I mean? So if this says a 2 factored out, you got to factor it in over there. I know that got a little confusing, but you got to know that 2 times 1 is 2, and if you want that to cancel out like it was never there, then you need a -2 to do that. All right, so the part that I think is the most confusing is that 2 right there. You have to times it by whatever you put in front. You have to times it right there by that. Now let's just go through and get the final answer. Y equals 2 is factored out. X plus 1 quantity squared is what that factors to. Might be like, but yo, what's the square root of 1? What is the square root of 1? It's 1. So this is correct, even though it's the same number, it's because the square root of 1 is 1. And then we got negative 2 plus the 5 plus 3. Who had the plus 3 before I even said it? Okay, awesome. Now, do you get, I have vertex form again? And so I know the vertex. And the vertex would be negative 1 comma 3. Okay, cool. So, that was the last kind, and that was the whole lesson for tomorrow. So let's just practice that one last time here and see if you've got tomorrow's hardest kind down. All right, so we're putting a y equals 4x squared plus 8x. And to save myself time, I'm going to put the plus 2 way the heck over there. Yep. And I know you could factor a 2 out of everything, but don't. This is the only time when you want to just factor that part. Remember, we only factored the first 2. Carter, did you factor out the 4 like I did? Now what do I do?
Can you put it in half and
Half of 2 is 1.
then square of 1 is 1.
All right. Is this a plus or minus?
Plus.
It'll always be plus, yes. And then what?
And then you subtract 2 from the outside.
So close.
4.
Yes. I would have subtracted 1. And if you even put in the minus 1, that's okay. But you got to times it by that. Final answer time. Mia. 4 in front, and then what?
X plus 1 squared.
Minus 2 is correct. Raise your hand if you feel like you got this. Awesome. Then we went from stuff that I feel like the lessons were really hard to this was kind of a hard lesson, but now we have 2 days to do it, okay? So tonight's homework is not going to even have this on it. It's going to be relatively easy. Let's start that together. Everybody find the homework that's assigned for today. In the October 29 folder. See the worksheet in there? All right, now it's a little too big. You know I try to be reasonable about cutting our assignments down to reasonable size. All right, so let's do cut off every D problem. Wherever there's a part D, cut it off. And I think that'll make it reasonable size. You gotta admit, we have a lot of time left today. I think you can easily finish this in class if you work at it. All right. So let's start with number 1A. Davidson, would you please read me 1A?
X squared plus 16x plus 64.
Now, there's no equation here, so there's going to be no vertex form. What is the directions? I mean, if it said y equals, maybe I could do the complete the square thing, but this is not a y equals. It says factor it. All right. Oh, that's just factoring. I knew that. X and X, and because there's only pluses in the problem, it's plus and plus, and then I got to think about what's going to multiply to 64. It's probably 8 and 8. Let's just make sure that that works. So you check it and you go first is x squared, the last is 64. So it's all about the outside and the inside, and that makes 16. Cool, done, that's it. Don't overthink this. Could you have put that together as x plus 8 quantity squared? Yes, but it's not wrong to leave it like this. I'm okay with that, and I'm okay with that. Either one's okay. Now, you can tell that this is kind of setting the kid up for later when they're completing the square. They're kind of like that, okay? All right, and I told you you could skip the D parts. Let's do 1, 2, skip a few. There's some that have graphing involved, and I want to talk through those. Could you tell me, what's the first one that has graphing, Colin?
3a, it's y equals x squared minus 6x plus 5.
Minus 6x plus 5. Now, would you read me the full directions about this? What am I supposed to do?
Complete the square to rewrite each of the following equations in vertex form.
Okay.
And graph your equation.
Oh, and then graph it. Can you tell if this one has a stretch? Yeah, it does not have a stretch. And does it have a reflect, like upside down? No, it's a right side up parabola. And if I just knew where the vertex was, it'd be easy, right? Have you figured out that the pattern, that if there's the vertex is here, then you go over one, up one, over one, up one. It's pretty easy from there, right? And then you go over 2 and up 4. Your next dots will be like here and here. So you'll be able to graph these really quick if you know the vertex. So how do we get the vertex? By doing complete the square. Ooh, but there's a minus in the problem. That makes it impossible. Of course not. Dylan Friday, tell me what to do.
First, you're gonna move the 5.
I agree.
Out of the way.
Putting it way over here, now what?
Then you're gonna half 6, and then square it.
Yep. Even though this could be a negative, I'm going to square it so it'll become positive 9. Correct. Now what?
Hold on, I gotta finish right. Then you gotta subtract 9 and put it on the other side.
Nice work. Final answer.
It'd be x, x plus 9, right?
You're so close.
Is it? Oh wait, no, wait. Minus 3, minus 3.
There we go.
And then squared.
Nice.
Minus 4.
Perfect. That's it. And now you know where the vertex is, which is at 3, 4. So you go over 3 and up 4. And you got this dot here. And then you know it's a parabola that kind of goes like that. If you needed exact points, go over 1 and up 1. Over 1 and up 1. That's the easiest one. And then from the original vertex, go over 2 and up 4. Or you can make an XY chart and find all the points you want. Okay, I think you have the idea. The only other thing I could see them asking from now is, since we already learned this stuff, do you get the axis of symmetry would be right there? Do you get, if they asked you for the domain, it would have been from negative infinity to positive infinity. And if they asked the range, it would be from here up. That's the range, is how low to how high. All right. Okay, cool. Now tomorrow, you've already learned tomorrow's stuff. I get to give you just a couple review problems and a whole bunch of work time. So you can factor that in if you have other things you want to work on tomorrow. All right, that's all I have for you for today.